Hello everyone, welcome to O for Organic. In this video we will be discussing about electromagnetic waves. Sunlight reaches Earth traveling in the form of waves. Sunlight is actually a mixture of a variety of waves like cosmic rays, gamma rays, X-rays, ultraviolet rays and a lot many. And all these waves are combinedly called as the electromagnetic waves. A wave is actually a sort of disturbance that happens in a medium. Whenever energy passes through a medium, it disturbs the particles of that medium and leads to the formation of a wave. If you ever tossed a pebble in water, you must have seen the formation of these kind of waves. Such waves are called ripples. To understand the formation of ripples, let us consider the example of domino effect. You all must have heard of it. In domino effect, a number of things are kept together aligned in a series. If you disturb the first thing of the series, it disturbs the next. And then this disturbance is carried forward and at last the entire series gets disturbed. This disturbance is actually the application of energy in any form. So we have a series of things aligned here and I apply energy to the first one. It gets disturbed and will further disturb the next in the series. The next will further disturb the next in the series and this disturbance will go on. And at last the entire series gets disturbed. If you closely see, you will see it is actually the energy that is being passed on from first to second and so on. When you tossed the pebble in water, it was actually the energy of pebble that passed into water. This energy disturbed the molecules of water coming in contact with the stone or the pebble. And just like domino effect, these molecules further disturbed the molecules nearby. And this led to water molecules oscillating up and down, hence leading to the formation of ripples. Electromagnetic waves are similar, but with two major differences. First, electromagnetic waves do not require a medium to travel. In the previous example, ripples were formed in water. There had been no ripples if there was no water. So water here acted as the medium. A lot of other things can act as medium, like air, glass, metals, etc. But electromagnetic waves, they do not require any such medium. So if there is no medium, even if there is vacuum, electromagnetic waves would travel. The second major difference is that electromagnetic waves are actually made up of two waves perpendicular to each other. And these are the electric field wave and the magnetic field wave. So what we were thinking of as a single wave is actually a combination of two different waves. And to understand these waves, we first need to understand what an electric and a magnetic field is. Let us consider an example here. Some animals are territorial. That means they make a territory around themselves. They stay in that territory, they hunt in that territory and are mostly found in that territory only. Lion is one such territorial animal. Wildlife experts say that lions do not allow any other animal to hunt in their territory. So from your point of view, you can say it is the region where chances of finding this fierce animal are the most. So the farther you stay away from the animal's territory, the safer you are. But the animal is free to roam around the entire jungle, so its influence is everywhere. Now this is where the territory comes in. The influence of this lion can be felt over the entire jungle, but it is the most prominent in its territory. So the farther you stay away from the territory, the safer you are. Electric fields are similar. Let us consider a charged particle here. We all know that like charges repel each other and unlike charges attract each other. So this positively charged particle will attract negatively charged particles kept in its vicinity. I have three negatively charged particles here, each kept at a little more distance than the other. Now this positively charged particle is going to attract all these three negatively charged particles, but the attractive pull felt by the nearest negatively charged particle would be more as compared to the other two. So we see as the distance from this positively charged particle increases, its attractive pull or its influence decreases. So we can say that this positively charged particle has a region around itself where its influence is maximum. And as you move farther away from this charged particle, its influence gradually decreases and ultimately becomes negligible at infinity. This region around this positively charged particle is called as its electric field. All charged particles, whether positive or negative, have their respective electric fields around themselves. And the strength of this electric field gradually decreases as you move farther away from the charged particle. So an electric field can be defined as the region around a charged particle where its influence can be felt. Similarly, all magnets have a region around themselves where their influence can be felt, and that region is called as the magnetic field. So now that you know what an electric and a magnetic field is, consider these fields in the form of waves. So we have something like this. One of them is an electric field wave and the other is the magnetic field wave. Here you see both the waves are perpendicular to each other. This is how an electromagnetic wave looks like. If you like the video, please don't forget to like, share and subscribe.